Welcome everyone. What we're going to be doing today is I'm going to be introducing a little bit of the basics of Pygame. It's certainly not a complete Pygame tutorial, but at the same time we're also going to be practicing with functions. So anybody who's trying to learn functions in Python may benefit from this video. What we're going to do is we're going to make this Space Defenders game, which bears no resemblance to any game from the 1980s. But we're just basically going to make this. It just has basic gameplay. It doesn't even have game over functionality, no sound effects, no music, but the basic functionality. And it'll give us an opportunity to learn some Pygame and to learn some functions as well. Okay, so let's actually get to it. So the first thing we're going to need to do is get Pygame ready. So I have a command prompt. Personally, I have Anaconda installed on my machine, but I'll use the pip installer so that everybody who has Python installed on their machine will also be able to follow along. If you've installed Python, then you should also have the pip command. If you're on Linux, by the way, just install the pip package. But this is included in Anaconda. So anybody that's had an Anaconda install should be able to use the Anaconda prompt, which has the path all set properly. And then here in the command line, just say pip install Pygame. I'm already installed, but that's what you'll need to do in order to get up to date. Okay, so we're obviously going to need to import Pygame. So let's do that. And I'm going to create a few constants just to make my code a little bit more readable. I like to make my constants all caps. So I'm going to create black, which is going to be a tuple, which consists of the red, green, and blue values. So black is the only color that I'm hard coding in my program. I'm using it for clearing the background. Let's all set our display size. So you can choose a different size if you want to. I'm going to pick 1000 by 800. We're also going to define how fast our player is going to move down at the bottom. And so I'm going to define a movement speed. This game is not going to be set up so that it handles different CPUs all that well. So you may need to adjust this movement speed as appropriate for your computer. All right, the first thing you always need to do in Pygame is call pygame.init. Which initializes all of the resources that Pygame is going to use. By the way, I'm going to be using some graphics. So I have this assets folder here, and in the assets folder are the graphics, which I've hand drawn. And so we have a couple different aliens. We have two frames of animation for each of the 3 different types of aliens. We have the bear, we have the ship as by, although I don't know if we'll implement that today, and then also the player. So these are really basic graphics to just sort of give a retro look and feel. Okay, anyway, so these assets, by the way, will be available on the GitHub repository. So if you want to follow along, you can download those. All right, so the first thing we're going to do is we're going to create a window. I'm going to call our window display. So display is equal to pygame.display. Set mode. And the mode is going to take one tuple, which describes both the width and the height. So I'm going to pass display width and display height. I will also set the title of the window. I'm going to call mine Space Defenders. You can call yours whatever you want. All right, and we're also going to need a clock. In Pygame, the clock keeps track of how much time has passed, and that helps us to redraw the screen at a particular rate. So we're going to define one of these. And finally, like in the first stage, we are going to load in a graphic to display just our player. So we're just going to handle the player functionality in the very first phase. So I'm going to say player image, and let's load in the image. Now, in order to load an image, I want to make sure that this works on any computer. If I'm running it inside Visual Studio Code, actually runs it with the working directory to be something that's quite different. If I was running this from the command line, I wouldn't really need to go to all this trouble. But what I'm going to do is use two built-in packages, the OS package and the sys package, which will let me figure out where the application is, like where the source code for this game is loaded. And I'll just look in a directory relative to that. So this is in a subdirectory called assets. Okay. So in our load function, I'm going to use the os.path. And this is because on every OS, the paths can be defined in different ways. This is Windows, which tends to use backslashes, and Mac OS and Linux and BSD and so on use forward slashes. So we'll just use this path join. So this is going to find out, this is the path, excuse me, this is the path that I'm going to merge. So I'm going to take two, I'm going to take the actual path, I forgot what I was saying there, the actual path to the file, but not the file name. And then I'm going to append to that a new folder structure, which is going to be Space Invaders. Invaders / player.png. So this is pretty complicated and kind of unnecessarily so. But anyway, we'll be using kind of the same system in the future. I will just point out that the actual proper way to do this would be using sprites. But I'm just trying to make a really, really simple game right now. I think in the future, I'll do another video where we'll create a different game and we'll use sprites in Pygame, which is a little bit nicer. Collision detection is a little bit nicer. Moving the image around is a little bit easier to do. But we're just going to load the graphic, and I'm going to maintain the position of that player and redraw the player whenever we need to. All right, I'm also going to keep track of where the player is on the screen. So I'm going to have a variable called player X for that purpose. And initially, I'm going to put the player in the middle horizontally. And we're going to put the player down at the bottom where it's supposed to be. Oops, no, display height. And I'll just put it 100 pixels from the bottom. This is kind of hard-coded this number into the game, which is probably not great because with a higher resolution, this would be a smaller space down at the bottom. So, but anyway, just a quick and dirty way of doing it. All right, so now we're ready for our game loop. And so our game loop is going to repeat as long as the game's still going on. I want to be able to handle in case the window, the X is clicked in the corner of the window. I want to be able to close the window. So I'm going to create a variable called game over. I'm going to set it initially to false because the game will not initially be over. And I'm just going to have a loop that says while not game over. And we'll just keep going. And inside the loop, I'm going to be doing two things. Okay, actually, eventually three things. So let's add them all in. First thing I'm going to do is check for user input. That includes user closing the window or hitting keys, using their gamepad, etc. And next, we will update game state. And then finally, we will display the graphical elements. So we'll just break it down like that. So first, let's do the user input part. Okay, so in Pygame, this works using events. And so there's actually going to be every single frame. That's what this loop represents, one frame of our game. Every single frame, some amount of time has passed. And it's possible that there could even be more than one user input event. So maybe the user hit a couple buttons. They clicked the mouse button really fast. So in this case, there's a loop within the loop that goes through all the events. So we're actually going to go for event in pygame.event.get. That function returns all the events that have happened since the last frame. And for simplicity, let's only check for one type of event. I'm just going to say if the event's type, so you say event.type in order to determine that, is pygame.quit, is the event that happens when you click the X in the corner of the window. And And I'm just going to set game over equal true, which will break us out of this loop. Okay? So this game doesn't do anything just yet, but let's just leave it there for right now. And what I'm going to do is we will just close the game code here by saying pygame.quit. It might not be necessary, but I'm also going to call quit to quit the application. Completeness. And now, even though we're not drawing any player just yet, we should actually be able to run this code. So I'm just going to run it real quick and see what we get. It just popped up on the wrong screen. Sorry about that. Actually, you know what? I'll just run it from the command line. Just things easy. Let me just navigate to the right folder here. Oops, I actually made a mistake. Sorry about that. Was looking over at the other path. This is not supposed to be. This is supposed to be os.path.join, and the first argument is sys.path. So os.path.join takes two things and kind of joins them together using the appropriate slash or whatever directory separator. And the very first argument is going to be the path to where our file is located, but not including space defenders.py. And then this is going to be the extra path that I want to add to it. And anyway. So let's keep dragging the window over. Anyway, that just gives us a boring old plain black screen with the proper title that we set up here. Not very interesting. So let's move on to the next part. So we're going to draw a player. So down here in display the graphical elements, I'm going to, oops, I have these in the wrong order actually. I'm first going to call display.fill with black, which will just fill it with black. As you could see, it already was black, but I'm going to do that anyway. And then we'll draw the player. So I'm going to say display.blit, which is a computer graphics term meaning copying a rectangle of pixels. And I'm going to blit the player image. And then you can blit it into a different spot. I'm going to specifically put it into player X, comma player Y, passed in as a tuple. You can also pass a destination rectangle, a source rectangle if you only want to copy part of the player image, but in this case, I want the entire image. All right, and at the end, we're just going to say pygame.display.update. And that's not update the game state, but that's just going to update the screen. So we're kind of drawing on a back buffer, which is an off-screen buffer. And then when we call pygame.display.update, it shows the back buffer on the screen. It's the active buffer. Now what we're going to do is we're going to tick ahead so that we go back. If you notice in the autocomplete here, you see it allows me to pass in a frame rate. We can shoot for 60. If you want to go higher, that's fine. For a game like Space Defenders, it's a little unnecessary. Okay, so now running this game, see what we get. You can see that we have a player down there. There's nothing we can do to interact with the player, so let's get that going. So that's going to be in our event loop. So up here in our event loop, I'm going to add another if. If the event.type is a key press event, so we have a key down event, which is basically when you depress the key, and there's another event that happens when you release the key. And so I'm just going to say if event.key is pygame.k_a, which just means which key. If they press the A key, so we're going to use WASD. And I think as an alternative, I'll also check to see if the key is equal to pygame.k_left, which is the left cursor. If that happens, then I want to move to the left. So how I'm going to do that is I am going to create a variable called dx, which is going to be our difference in x position. And I'll create that outside the loop here and just keep reusing it. And what I'm going to do is I'm going to set dx equal to our movement speed. But our movement speed is a positive value. And if we're moving left, we kind of have to move in the other direction. So I'm going to actually say negative movement speed. Okay, so if you push the A key or the left cursor key, we're going to set dx to be negative movement speed. That's not going to do anything to the position of our character, but it'll set this dx value appropriately. And then I'm going to say, well, otherwise, the event key could be pygame.kd, or it could also be the right cursor. Okay. And in that case, I'm going to set dx equal to positive movement speed, which will make it move to the right. And if I have a key up event, as long as I'm holding down the key, I'm going to keep moving left. I'm going to keep moving right. But if I ever have a key up event, oops, then I'm just going to set the dx value to 0, so I stop moving left or right. This won't have any effect. Maybe I should put some comments in here, make it a little bit more understandable. But then eventually I'm going to actually change the position. So after I'm done with the loop, I am going to, oops, actually I was wrong. This is actually supposed to be above here. Sorry about the confusion today. I didn't get ready for this quite enough. All right, so updating the game state is going to be really simple. All we're going to do is change the player's x position. The player is never going to move up or down. So we're just literally going to say, whoops, we're going to say plus equals dx. Let's give this a try. Dragging this over, there is our player. Left and right on the keyboard, A and D on the keyboard. You can see as long as I hold it down, I keep moving. I can also tap, but as soon as I let go, it stops moving. That's exactly what we want. So that's smooth arcade style interaction. All right, so that's kind of step one down. The next step is let's add some Space Invaders. Okay, so I'm going to create a function for this purpose. And the function is going to draw our Space Invaders. I shouldn't put all this in one file, but this is supposed to be a pretty quick game. In the end, it's only going to be like 100 lines of code, so it's not going to be a very difficult game. But I'll put it all in one file. But of course, the proper way to do this would be to put it in separate files. Again, I'll worry about that next time because we'll probably end up using classes and things like that in a future tutorial. Okay, so I'm going to create a function called drawAlien. And the alien is going to have 3 arguments. First of all, I'm going to have to know where to draw it on the screen because we're going to have a whole array, basically a rows and columns of our aliens. I want each row to have the exact same alien, but I have 3 different types of alien that are possible. So the first argument is going to be which alien are we dealing with? And so this is the alien index, we'll call that. And then we'll also pass in the x and y coordinate where we want to draw it. And over time, I want the aliens to kind of slide back and forth on the screen like they did in the arcade game, or in some arcade game. All right, so anyway, then what we're going to do is we're just going to say if index is equal to 0, then I'm going to say display.blitz. And then we're going to have to load these images, but for now, I'll just pretend that we've already done so. I'll just say alien1 images. But because these are animated, then I'm going to need to pick the correct frame. So I'm going to actually load these into an array, and I'm going to have a variable called alien frame. It's going to determine which frame. There actually are only 2 frames in every animation, so alien frame is just going to flip between 0 and 1. All right, and then we're going to draw it at the x and y coordinate, and Pygame likes you to pass it in as a tuple, so make sure you put round brackets around it. And then I'm just going to duplicate this, and this will be an elif, I guess, and if we are using index 1, and I also want this, so the first row of aliens is going to be one type of alien. The next two rows of aliens are going to be another type of alien. So I'm going to actually say if the index is 1, or the index is 2, then I want to show alien 2 images. Then similarly, the third and fourth row, or the index 3, index 4 row, is going to be the third type of alien. So let's actually load these in. So we have to use the same functionality that we use down here. So I'll just copy that, I suppose. So maybe just after the player, I'm going to create alien 1 images. It's going to be equal to an array. And that array is going to have 2 images inside. So I'm going to say, let's just copy this. And the graphic, of course, is going to be alien 1-1. So if we look back at our folders here, we've got alien 1-1, which looks like this. And then the other frame of the animation looks like this. So we're going to kind of alternate back and forth between these two. So this is alien 1-1, and then the other one, of course, is going to be alien 1-2. Other frame for the alien 1. All right, so let's duplicate this 3 times. And this is going to be alien 2 images, and this will be alien 3 images. Of course, alien 2 images are going to be alien 1-1 and alien 2-1 and alien 2-2, and alien 3 images are going to be alien 3-1 and 3-2. Just to see here, these are the 6 images that we're going to be using. All right, now for right now, there's actually no way that that we can kill any of the aliens because we're going to add the missile functionality in the final step. But eventually, I'm going to keep track of which aliens have been killed. And so for that, I'm going to be using a list of lists. So I'm going to say aliens, and basically that's just going to be for the each row and column. So for each row, I'm going to have a list of whether or not that alien is alive, and I won't draw the alien if it's not alive. So initially, this is going to be set to true, and we are going to have 8 aliens across. I'm just going to have, and we'll just do that 8 times, and I'm going to have 5 rows of aliens. We'll set them all to true for now so that all the aliens initially are there. Okay, so first things first, let's do this, and then we'll add the barriers. So I'm going to need a position because the aliens are going to kind of slide across the screen. I'm going to create a few more variables. I'm going to say alien X. Let's set it to 50, so it'll be 50 pixels from the left-hand side of the screen. And then the spacing in between them, because this only kind of describes the first alien's X position. The alien spacing, oops, I called it X spacing. Alien X spacing is going to be equal to 100, so there'll be 100 pixels in between the leftmost part of each alien. And similarly, we're also going to have an alien Y, which is going to be 80. But then I'm also going to have the spacing here, which is going to say how far apart should the rows be. I'm going to set that to 80 as well. Okay, we're also going to need our alien frame variable, which if you remember, which is going to be set to between 0 and 1, which is going to determine which of these 2 graphics in whichever alien images array we're talking about, we're going to be showing. That's what we're going to do. And then what I'm going to do is keep track of how many frames, because I don't want the aliens to animate at 60 frames a second, because that'll look quite funny. So what I'm going to do is I'm going to keep track of how many actual frames in my game have passed. So I'm going to have something called frame count. And when I get to a certain quantity, then I'm going to flip, excuse me, then I'm going to flip to the other frame. So it'll animate at something like 1 frame a second, but our game won't be 1 frame a second. Okay. Next is we're going to have to go and I think I'm missing something actually. I need a couple more constants. So up here in the constant area, I suppose, best way to do that. We're going to have alien movement speed, just like with our movement speed. I'll set the alien movement speed to 16. Then we're going to have the frame delay, which if you remember, that is how many real frames we're going to wait before we do the animation. So let's set it to 20 and see what it looks like. But as I said, this will end up being like 3 frames a second because we're going at 60 frames a second. Every 20 frames, we're going to change the alien's animation frame. All right. And then we're going to say alien movement max steps. And this is going to be the number of steps over that we're going to move. So we're basically going to jump over and just kind of give that 80s retro feel. It's going to, rather than smoothly move over, it's going to pop over by a block. And we're going to move 6 times, 6 blocks. Okay. Anyway, so but we're also going to need a variable to keep track of how many steps we've taken so far, and I forgot to do that, so let's do that right now. So down here I'm going to say alien movement steps, set that to 0, and when I get to 6, I'll go back to 0 and start heading back in the other direction. Okay, so the next thing is to actually take care of that. So first, let's have it draw the aliens. So this will be the player. It'll be a little bit better with our comments. Okay, so drawing the aliens is going to be a matter of looping and drawing each individual alien. So for starters, currently alien frame is set to 0, and I haven't really moved the alien at all. So that's actually fine. So I think what we'll do is I'll just draw them static right now. I'm going to loop over all the columns, and we're going to be drawing 8 of them. So I'm going to do a simple for loop for that, 8 columns. And then I'm also going to have another loop for the rows. And the rows are going to be 5. These are hard-coded right now. Of course, I could pull these out. And then what I'm going to do is check to make sure the alien is alive. That way, eventually, all I have to do in order to make the alien disappear is to set its alien alive at the proper index for the row and column for the alien that gets hit to false, and then I won't draw it. I'm going to say if alien's alive at position row column. If it's true, then we're going to, first of all, figure out where to draw it. And so I don't know where to draw it just yet. So what we do have this draw alien function. We're going to draw it, which row we're in, that's the index. And then we have the x and the y value, which we haven't figured out yet. So we have to do the x and the y value. For that, this is getting huge here. I think we should make another function. So up here where we have the function definition, draw alien, let's make another function that's going to figure out where the alien should be. Okay, so I'm going to make a function called alien bounds. And I'm going to pass in the row and column of the alien that I want to draw, and then we'll just do the calculations. Okay, this is, again, going to just be a really simple way of doing it. We're going to take the leftmost position, which is basically the alien x is the position of the leftmost alien in each row. And I'm going to add to that which column we're in, brackets just to make it a little clearer, times the spacing. Okay, so if I'm in column 3, which is really the 4th one over, it's going to move over alien spacing times 3. And if I'm in column 0, of course, I won't move over at all. And do the same thing for y. I'm going to have alien y plus the row index times the alien y spacing. And then I'm just going to return. I'm going to return an entire rectangle because I might use this function later. So I'm going to return a tuple that consists of the x and the y position, but also the width and the height. And for now, I think for simplicity, I'm just going to hard code the actual width and height of the graphic files that I used for the alien, which happens to be 96 by 96. These, by the way, these graphics files are actually a little bit bigger than they need to be, as you can kind of see here. And that means that if I shoot at it, if I hit the spot doesn't seem to be where the alien actually is, there'll be a lot of forgiveness and it'll still count as a hit. So you might want to decrease the size of these graphics in order to account for that. We'll just make our game easier, which I don't think is the worst idea. Okay, so then what we're going to do is down here where we're drawing our aliens, I'm just going to call that function in order to get our x and y. We're not actually using the width and the height, but I call it alien bounds. And we're going to pass in the row and the column. And then draw alien will actually copy the graphic, the appropriate graphic to the screen. All right, let's see what this looks like. This is not going to have moving aliens, but it's a good start. So there we go. So we can move our layer around and the aliens appear on the screen. You can see this is row 0, row 1, row 2, row 3, and row 4. And we have 8 columns of them. So it looks pretty good. And of course, you can play with all those constants in order to get them to spread out. Certainly, it actually does make sense for me to put these in a constant as well. So I could, change the number of aliens that I have. Okay, so that's really good. Let's add the movement now. Let's add the animation first. Okay, so I think what we'll do is we'll update the game state up here. And so, excuse me. So let's animate the aliens. I'll kind of break that into 2 parts. One, I'm going to flip back and forth between the different frames. So I'm going to say frame count. So frame count, if you remember, is the number of actual frames. So every single time I encounter an actual frame, which is once through this loop, I'm going to increase the frame count. And I'm just going to double check to make sure that I didn't go past the frame delay. So I'm going to say if frame count is greater than the alien frame delay, then what I'm going to do is, first of all, I'm going to restart the frame count at 0 so that I can do it again next time. But I want to do 2 things. I want to move the aliens either to the left or the right, and then I want to change the animation frame. The simpler one to do is just to change the animation frame. So I'm going to say that was alien frame, if you remember, and it's supposed to basically be either 0 or 1. So what I could do is I could set it to alien frame plus 1, basically, and that'll just put it to the next one. But the problem is eventually I'll run out of frames to show. So what I'm going to do instead is I'm going to use the modulo operator here to make sure that after I get to 2, I go back to 0. So I'm going to use the modulo operator with 2 so that it goes back to 0. Because I changed this alien frame variable right here, down here in the alien bounds function, the alien frame variable is going to be updated. And so it'll show the other frame of the animation. So let's watch what that does. Yep. Our little aliens are animated. Adorable. Supposed to be terrifying, but they're not. All right, so then the other part is going to be moving the aliens back and forth, which we're going to move. I think I had it set to 6 steps. And so we're just going to be basically moving over a little bit. I'm only going to modify the alien x variable here. rather than the Y, because we're not going to be moving down. I know in the classic arcade game, the aliens move down and eventually attack the player, and they also speed up. But just to keep things simple, we'll just have them move back and forth. They kind of need to move back and forth because the barriers are in the way. You can't shoot some of them sometimes. All right, so we're just going to say alien X is going to move over. We'll just say plus equals alien movement speed. Just going to make it move to the right. And then basically I'm going to check to see if I'm all done. I want to just remember that I took a step. So I'm just going to increase the number of steps that I've taken up by 1. Then I'm just going to check to see if I'm done moving to the right. And if I am, I'm going to say alien movement steps is greater than alien movement max steps. And then what I'm going to do is I'm going to start moving to the right. But actually, I'm going to use a little trick here in order to do this. I'm just going to change, in order to do this, I'm just going to change the movement speed to the opposite. I'm just going to multiply it by -1. So the movement speed, which initially is positive, is going to become negative. And when I add that negative value to our position, is going to make us move to the left. And then eventually, when I have a negative movement speed and I move 6 steps, it's then going to change it back to positive by multiplying it by -1 again. But whenever I do this, I have to start over the number of movement steps, setting that to 0. So this will actually count up to 6. When we get to the 7th one, I'm going to set the movement speed to negative and start over the count of steps. So, and then I'm going to take the same number of steps in the opposite direction, and then it'll flip to positive again. All right, so let's run this and take a look at what the result is. So it takes 7 steps in each direction. So we have this set to 6 steps. So if we actually wanted to move 6 steps, I think 7 is actually right. But if we want to move it to actually move 7 steps, then what we do here is I would make it so that if it is equal to the number of steps, then it'll take 6 steps. So I guess that's fine. Just won't move quite as much. Anyway. Now, so that's mostly it for this round. And so I will also load in the barriers, because the barriers being there is pretty important. We can't shoot yet, but basically let's set up for when we are able to shoot. So this is all alien related. Maybe right after the players here, I'll get the barrier stuff going. So first we'll load the barrier image, which is going to be .image.load. And I'm not going to type all this out again. It's the same. And the barrier is called barrier.png. Okay, so we load the image. I'm also going to have a position again. And there's going to be like an array of these along the bottom. So I'm going to position the first one at position X. And I'm also going to use kind of the same technique. I'm going to create something called barrier X spacing, just like I did with the aliens. And I'm going to space them apart by 200 because the graphic is quite large. And we'll also have a barrier Y position, which is going to be the Y position for all of them because they're just all along the bottom. So I'm going to set that to display height minus 250. Again, I've hard-coded the difference here, just like the player. So as the resolution gets bigger, the spacing on the bottom is going to get smaller and smaller. Might not be what I want. Okay, so now actually all I need to do is add some code in order to draw the barriers. So let's actually do that. So I'm going to go down here. Doesn't matter if I draw it before or after the aliens. I think before makes more sense because the aliens code is pretty long. So I'm just going to say draw the barriers. Oops, sorry, I'm in the wrong section here. Got to be down where we do the drawing. So after draw the player, all the barriers. And so I'm just going to loop through. We'll say just for barrier in range. And I'm going to draw 4 of them. I'm just going to use another function. Just like we did with the aliens, I'm going to create a function that returns the boundaries. And this way, if I swap out other images, it's kind of easy for me to do because I'm going to use that boundary in a couple different places. But basically, I'm going to use this exact same code, except I'm going to write a function that does it for the barrier. So I got so we'll call this barrier bounds. And oops, draw barrier. There aren't multiple barriers, and so I'm literally just going to pass in. Actually, it's kind of unnecessary because this is actually so simple. What we could do is just do display.zip directly, just like we did with the player above. So we'll do barrier image, and then I'll pass to it the X and Y position, which is what I'm going to get back from this barrier bounds function. Oh, sorry, not row and column. It's going to be which one, because we don't actually have multiple rows of barriers. So I'm going to pass in the barrier. Let's maybe call this index instead of B. Be more readable. And then we'll create our barrier bounds function by just modifying the alien bounds function. So the barrier bound function is going to have different values because, of course, the barriers graphic is a little different. So what I'm going to do is we don't need to calculate any Y stuff for the barrier. And it's going to take an index. So what we're going to do is I'm going to figure out the X by saying barrier X, which is the X position of the very first one, plus the index times the barrier X spacing. That's going to figure out our X value. Whoops, I didn't declare that here. That's okay. Sorry, it's supposed to be, yeah, I called it spacings. That's actually incorrect. Okay, so barrier X spacing, and then we're just going to return X, and for Y, I'm just going to put in barrier Y rather, and then the size of the barrier is, well, we'll make it 96 again. Okay, I think I might have forgotten something, but let's try to run it just to see. Oh, I guess it's actually okay. So there's our barriers. This is actually a little bit off, so maybe I should position these a little bit better. To do that, of course, we go down to barrier X, and maybe I'll change this to 200. Not overly worried about it. Okay, 200 was too much. So make it 150. It's kind of middle, like, hey, looks good. Almost looks like we've got ourselves a game. So next step is a missile. And the missile's so ridiculous. Like, there is an actual graphic, but it's literally just a rectangle. So I could totally draw this using a rectangle. For simplicity, though, because later on we may want to swap this out for like more realistic graphics, I won't do that. Okay, so what we're going to have to do is load our missile. So let's just do it where we load the barrier. Excuse me, sorry. So I'm preloading it, even though I'm not necessarily going to show it. Actually, first, before we do that, let's add some constants that have to do with the missile. Okay, so we're going to have constant. This X offset is, let me actually run the program before I save this. I want the missile to kind of start relative to the player, but the player's position is defined in the corner. I want the missile to kind of start right here. So that's what this offset is. It's how far over I want to move the missile when we draw it, and this is relative to the player's position. And so I've prefigured out a value that I think looks okay as 42. And then similarly, I also need to scoot it up a little bit so it looks like it's coming out of the front of the gun. And I've already figured out a value. It looks like 48 looks pretty decent. And we're going to create the missile movement speed, which I'm going to set to 16. However, I want it to move up, and the up direction is therefore negative. Okay, so those are those constants. So let's actually load the image now. So down here, let's just copy this code. So this is going to be missile image. And it's called missile.png. I'm going to have a missile X and a missile Y. Is its current value, because of course it's going to be animated as it goes up the screen. I'm initially going to just set it to 0 because this is a meaningless value until I actually fire, because I don't actually want the missile to show up until I actually shoot it. So I'm also going to have another variable called show missile, because unlike most of the others, I want this not to show up until I actually do something to it. Kind of the opposite of the aliens, because the aliens show up by default until I actually hit them. Okay, so we are going to want to draw the missile. So I'm going to create this show missile variable. And then down in the draw code, so going down here, we're going to have, and the order, by the way, does matter because it'll draw it on top. So if I want the missile to show up kind of on top of the player, I should draw it second. Something to keep in mind. So drawing the missile, I can say, for instance, sorry. I'm just going to say if show missile is true, then I'm going to just use a doublet just like we did before, and this is going to be missile image. Then the X and Y position are just going to be the missile X and missile Y. Seen that before, so not a lot of explanation should be required there. So this is going to draw our missile. So let's actually see whether I missed anything and also what it looks like. There is our code. We haven't actually created any code to spawn the missile, so that's silly. Of course, it's not going to do anything. So yes, I missed something today. So we're going to have to add another thing to our event loop, first of all. So up here, where I'm checking to see the user's key presses, I'm also going to check for one more key press. I think space is probably the most appropriate one. And I also want to make sure that if there's already a missile on the screen, this is kind of in keeping with the classic game. If there's already a missile on the screen, I can't shoot again until the missile goes off the screen or it hits an alien and therefore disappears. So there can only be one missile at a time. I think this was probably due to hardware considerations back in the day, but for retro reasons, let's keep it doing that. So I'm just going to say and not show missile. So in other words, if show missile is set, that means there's already currently a missile being drawn on the screen. And so if it's set to false, then I can shoot. So when I do this, I'm going to say set show missile to true, which will draw the missile. And then I also need to specify the position. So I'm going to say that the missile's X position is going to be the player's X position plus that offset that we defined. And similarly for the Y, almost exactly the same code. Missile Y offset is going to be, plus player Y is going to be the missile Y position. When it finally draws, it's going to draw it at the appropriate spot. It's not going to animate anywhere, but at least it will start to draw it. Okay, so I'll just make sure I save that, and let's run it. Okay, they must have screwed something up. That's okay. That's okay. Before we do that, anyway, let's also add the movement. So I'll figure out why this is not drawing. But anyway, so show missile is set to true. And we're saying if show missile is set to true, then we're blitting that missile and I'm passing in the appropriate spot. Hopefully it is loading the graphic properly. Missile.png, just in case I maybe typed that incorrect. Looks like I did not. Okay, so then we'll let's actually animate the missile. So we're gonna have to in the update section, kind of blank space here. This is sort of like a bigger comment for the whole section, and I would normally put this into its own function, but for right now, this is okay. So animating the aliens, animating the missile. Let's actually do it up here, kind of keep the consistent order. We'll just say, I'm going to say if we are currently showing the missile, then I'm going to say missile Y, add to it the missile movement speed. So if you remember, missile movement speed is -16, which is going to make the missile move up the screen. Okay. There we go. Okay. It's just drawing it inside the inside here, and since it was the same color, anyway, that was the problem. Okay, great. And we can't fire yet because right now I have no way of not showing the missile. So it technically is still showing, even though I'm not drawing it on the screen. I'm drawing it somewhere off the screen. So I have to have some kind of check that says whether or not the missile has gone off the back here. And eventually, once we start doing collision detection, we'll also have that as another case where the missile will explode, and therefore I can create a new one. Okay, so in the update code, we're just going to check to make sure that the missile is not off the screen. So right here, I can just check to see if missile Y, let's say, what if it is negative? Because we're kind of subtracting a value. We're subtracting 16 from missile Y each time. If missile Y eventually becomes negative, it's not going to be drawn on the screen. And so in that case, I consider that missile to be sort of gone. So I'm just going to set show missile to false in that case, which will allow me to shoot again. Okay, so let's test that out. Can't shoot until it actually does leave the screen. So I'm just continuously pushing it. And you can see it doesn't shoot until the missile's off the screen, and then it does. Good. So we only have one more thing, and that's the actual killing of aliens, and that's what we're here for. So let's make sure that we can do that. So in order to do that, I'm going to need some more functions because we're going to need to check to see if we hit the alien. Okay, so I'm going to create a new function that's going to check to see if I hit a specific alien. I like to put all my functions up at the top. This is turning into a huge mess. So I'm starting to regret my choice popping all this one file. But anyway, so I'm going to create a new function called hit alien, which is going to return true or false, depending if we hit an alien or not. And so I'm going to say the missile position, I'll pass that in. And the reason why I'm kind of mixing global variables like here and arguments is I wanted to use this to illustrate a really important point about the quality of the code. So in the next tutorial, we'll kind of stick to the strict rules about not using global variables. But in this case, hopefully everybody can see that we've got these global variables like barrier X, barrier Y, and barrier spacing. And those aren't defined inside this function. So I need to think outside the function in order to understand all the things that the function is doing. And that can be very confusing. Plus, this variable might end up getting changed, which I think would be really strange inside a function. So that could be very confusing for me. And also, if I'm on a team, then that could be very confusing for the rest of my team. So I really want to make sure that that doesn't happen. So as a general rule, you should pass in all the values that you need inside your function, rather than accessing these global variables here. Okay, so that's just a general best practice. For hit alien, what I'm going to do is I'm going to pass in specifically a row and a column of the alien I'm currently checking, and I'll have to loop through all of the aliens in order to check to make sure that it works. And I'm going to use the alien bounds function in order to do this. So I'm going to actually call it. So it gives me the x and y and the width and the height position, width and height of our alien. So I'm going to call alien bounds of the alien at row and column. And then I'm just going to check to see if the missile's position is somewhere inside that rectangle. So first, we'll check to see if the missile x value is less than the x position that we just figured out. If it is, then we're not inside the alien. Okay? Or if the missile x position is greater than the x position of the alien plus the width. In other words, if I'm past the right-hand side, then I'm definitely not inside the alien. So I'm using this in an or case. And what I'm going to do, I'll add 2 more cases to this. But basically what I'm going to do is I'm going to return false, because I know if it's too far left, this is too far left, I'm not hitting the alien regardless of the y value. If it's too far right, I'm not hitting the alien regardless of the y value. I'm not hitting this one anyway. And then I'm going to check the y values in the exact same way. That's why I'm using or, because any one of these things is enough for me to know that it's not hitting this particular alien. So I'm also going to check the y value. So I'm going to say if the y value is less than the y value of the alien, then it's not a hit. That's too far up. And then or missile y, if the y value is greater than y plus the height of the alien, then that is too far down. And so that function actually will return true if, well, I'm not quite done yet. It'll return true if the missile position is within the boundaries of this one alien. And of course, this could be simplified just to return the result of all these ors, basically equivalent to what we just wrote, and maybe a little nicer. All right, so there's our hit alien function. So what we're going to do next is check to see if we do have a hit. We also have to check to see if we hit the barrier as well, because like I can't shoot through the barriers. Now, I know in the actual original game it was like destructible, but we won't have that facility in our game. All right, so the next thing we're going to do is the barriers themselves don't generally change. So all I need to do is check to see if we hit. Okay, so that's going to be in our update section. So I'm going to go to our loop, and we're going to have the section where we check for user input is the first section. Checking the update is the second section. And let's figure out where the missile's new position is first. And then we draw the aliens. So I think the best thing to do is once I want to check to see if it was hit, I'm checking to see if it was hit on the previous iteration. So before the missile moves and before the aliens move, that'll be a hit. So I think we'll do that right here. Also going to have to do check if the missile the barriers. Okay. Well, first, let's check to see if it hits the aliens, because we're going to use this function that we just made. And so I'm going to basically loop through, just like we did before. Again, I've got that same magic number here, 8. And so this is a definite candidate where I should pull this out and make it a constant. 5 rows, that should be another constant. And basically, I'm just going to check to see if, first of all, I want to make sure the alien is still alive. I'm going to actually say, is the alien at that position still alive? Because if it's not alive, I want the missile to go right through that space. So I'm first going to check that. And next, I'm going to use our function to check to see if it's a hit. So I'm going to say missile X, missile Y, and then the row and the column of the alien that we're checking. But both of these two are true. It means that the alien is drawn, and so I should be able to hit it, and the missile is within the rectangle border of the alien. So we're just going to basically kill the alien. So this is before the drawing because I want the alien to disappear. We'll just have it disappear rather than have an animation. So I'll just update aliens alive at row call be equal to false, which will stop it from being drawn. I will also turn off show missile so that I can shoot again. And then I'm also going to set the missile's position. If I don't do this, I'm still checking to see if the missile will hit things, even though it's not being shown. So I'm actually going to set it to -1 so that it doesn't hit anything. Just temporarily, because once I shoot again, I set missile X to the player's position plus the offset, and missile Y is the same. So this is going to check to see if the missile hit the aliens. Let's check to see if the missile hits the barriers. We should actually make sure I'm doing this in the correct order here. So we drew the player, then the barriers, then the aliens. So actually, it makes kind of more sense if we check to see if we hit the barriers first. So for the barrier, we're just going to say for index in range, and I'm going to have 4 barriers as usual. All we're going to do is use another function. I'm going to say if hit barrier. We're going to write in a moment. And I'm just going to pass in the missile X and the missile Y and the index of the barrier. If that's true, then what I'm going to do is just make the missile get absorbed. So I'm going to say show missile false. So I can shoot again, but at the same time, it doesn't continue on to do any damage. And then that's it, actually. We're just going to have to only define that hit barrier function. So I'm just going to define that now. So let's go up to the hit alien function. And let's just keep the ordering the same. Hit alien should come second. Barrier stuff first. So we'll pass in the missile X and the missile Y and the index of the barrier. And it's basically going to use almost exactly the same code here. So I could probably make this a common function. So all I'm going to do is call barrier bounds. And then it's just going to determine the position. So barrier bounds in this case just takes the index. And it returns all the correct values. So we could actually use the exact same code again. Now the Y value is always consistent, but so I'm kind of doing some calculations that I don't really need to do. Oh, I have a colon at the end here. Whoops. Let me trim that out. That was there when it was an if statement, and it's not now. Okay, let's see what we've got here. It's possible I missed something. I like to run frequently. Okay, we have a bit of an issue here. And so you can see none of our aliens are showing up. Not sure what's going on there. So maybe this is returning true unnecessarily. So if the missile X is less than X, or the missile X is, oh, actually, I'm sorry. This is actually completely the opposite because this is what happens if we didn't hit. So I actually have to reverse this whole thing. That's true. So basically, that's why. No, the missile didn't hit any of them. I had this reversed. So it was hitting all the aliens and all the barriers. Here we are, anyway. So now I can move, I can shoot, I missed. There we go. So you can see it disappears. And we don't have any code or anything like that to handle what happens if we kill everybody. But, so we can also hit the barriers, it absorbs. It's pretty decent. Now, if we hit somebody, by the way, up at the top, I'll see if I can kind of just graze this one. No, very good at that. It actually will hit way off, especially on the green alien, which isn't quite as wide. So we could easily fix that by just having the aliens be a different size. I just would need to be careful that I get the correct bounds when I call alien bounds, so it's not this consistent size. The way to do that, the proper way to do that, would be to make everything into a class. And so I would have an alien class, which would draw one of the 3 different aliens, depending on which one I designate it, and it would automatically update its position in the same way that we're updating the position, and all of that alien update code would all be pushed off to a separate file, which would make this program a lot simpler. But as I said, for the first round, we're kind of just focusing on functions here, and so for the next tutorial, I'll do a different game, and we'll use classes for it, which will make it a little bit cleaner. And because it's nice and compatible with Pygame sprites, we'll also use Pygame sprites. All right, anyway, so this code will be posted in the repository that I'll share with you, but just to keep in mind, it's not the same thing for you downloading and looking at my code. I would strongly recommend that you give it a try on your own, because you'll get a lot more from it. Try the code. If it doesn't work, you can compare side by side if you absolutely need to, but it's really good to struggle a little bit and get a little bit of practice with that, because you learn a lot actually through that failure and figuring out what was wrong. You start to recognize that in the future, and you avoid that issue much more, because it kind of costs you some of your time. Anyway, so there'll be another one of these in this series a little bit later, in a few weeks perhaps, that will help us practice with classes in Python. All right, everybody have a good day. Talk to you later.